In previous videos, we have already covered what chemical bonds are, how to show an ionic bond, and how to show the covalent bond between two atoms of the same element. Those are called diatomic covalent molecules. If you need a refresher, I would suggest you go back and watch the ionic bonds video or the beginner covalent bonds video. In this video, we will discuss examples of covalent bonds between atoms that are not the same element. These molecules could end up having a slight charge and being called a polar covalent bond, or have no charge and be called a nonpolar covalent bond. First, we'll review how to figure out the number of valence electrons. Then, we'll discuss electronegativity. We will start each of our examples by showing the electron-dot diagram. We only need the electron-dot diagram because the valence electrons are the only ones involved in chemical bonds. We don't need to include the protons, neutrons, or inner electrons. We would need to use the pattern for valence electrons to make this easier. Here's that pattern. All elements in group 1 have one valence electron. That means it has one electron in the outermost shell. Group 2 has 2, group 13 has 3, group 14 has 4, and so on. We also need to work out the difference in electronegativity values for the two bonding elements. Electronegativity is basically how strongly an atom pulls on other atoms' electrons. This is really important because we think of atoms as being neutral, but in order to form a chemical bond, the atoms will either transfer or share valence electrons with other atoms and try to fill their outermost shell. This can result in the atom having no charge, a slight charge, or a full charge. We can see from this periodic table that as you go across a period, the electronegativity tends to increase. Not every element follows that pattern, but for the most part they do. As you go up a group, the electronegativity also increases. So the highest number is fluorine, 3.98, and the lowest number is francium, 0.7. We can figure out whether the bond will have no charge, called a nonpolar covalent bond, have a slight charge, called a polar covalent bond, or have a full charge, which is called an ionic bond and is discussed in a different video. To figure out which type of bond will occur, we need to find the difference in electronegativities between the two bonding atoms. If the difference is around 1.5 or higher, then it is classified as an ionic bond. If the difference is about 0 to about 0.2, it's called a nonpolar covalent bond. This means the electrons are equally shared between the two atoms. If the difference is between 0.2 and 1.4, then it's called a polar covalent bond, and the electrons are shared but not equally. Let's try some examples. When carbon bonds with 4 chlorines, we can figure out if it's ionic or covalent. We got to look at the periodic table and get their electronegativities. Chlorine is 3.16, carbon is 2.55. We subtract them, and that is 0.61. That's between 0.2 and 1.4. So this bond would be called a polar covalent bond. That means the edge of the molecule would have a slight positive and a slight negative charge. In the second example, 2 chlorines are bonding together. We would call this a diatomic molecule. Now both chlorines have an electronegativity of 3.16. When you subtract, you get 0. That means that these form a non-polar covalent bond. That means the electrons are shared equally around both. Neither side of the molecule has a slight charge. This next example is potassium bonding with chlorine. Chlorine we know is 3.16, and you can use the periodic table to figure out the electronegativity of potassium, 0.82. The difference is 2.34. That's above 1.5. This is an ionic bond. That means electrons are going to be transferred. This will be covered in a different video. Why don't you try the last 3 examples? Pause the video, determine the difference in electronegativities, and determine if the bond is ionic, a nonpolar covalent bond, or a polar covalent bond. The answers will be shown after you resume the video. I hope you got them all right, but check your work just in case. If you watched the previous video on covalent bonds, you would have noticed that all we covered were atoms that bonded to an atom of the same element. It's called diatomic. That's not always the case. We're going to look at some examples of atoms forming covalent bonds with atoms of different elements. We will start by finding the number of valence electrons and making an electron-dot diagram. We will then show the atoms sharing valence electrons to fill their outermost shell and form a covalent bond. Let's start by showing the chemical bond between a hydrogen atom and a chlorine atom. They will form a substance called hydrochloric acid. Hydrogen has 1 valence electron. It needs 1 more to fill its outermost shell. Chlorine has 7 valence electrons and also needs 1 more to fill its outermost shell. The chlorine is pulling on hydrogen's electron, and the hydrogen is pulling on just 1 of chlorine's electrons. Both atoms are trying to pull the electron into its outermost shell and fill it. Think of it like a tug-of-war match, where the stronger element will pull harder on the electron and pull it closer to it. Let's determine which element is stronger by finding the difference in electronegativities. Chlorine is 3.16, hydrogen is 2.2, so the difference is 0.96. This is a polar covalent bond. Since neither element is strong enough to totally pull the electron from the other element, the 2 electrons end up getting stuck in the middle, and we say that they are shared. We call this a covalent bond. We write it using an electron-dot diagram, where the pair of shared electrons are placed between the 2 atoms. We write the chemical formula as HCl. You will often see a single bond between 2 atoms, that's 1 pair, or 2 total shared electrons, written like this. The 2 shared electrons orbit both the chlorine and the hydrogen. The 6 valence electrons from chlorine that are not involved in the chemical bond will only orbit the chlorine. That's not the end of the story here. We thought of this scenario like a tug-of-war match where both sides are pretty strong, but chlorine is just a little bit stronger. That means that chlorine is able to pull the electron closer to its own outermost shell, but cannot pull it all the way away. If it was strong enough to totally take the electron, then it would be called an ionic bond. There's a different video on ionic bonds. So hydrogen and chlorine will not equally share the electron. When this happens, we call it a polar covalent bond. Since the electron is closer to chlorine, the chlorine ends up with a slight partial negative charge. We don't write a 1 minus charge. We put this funny looking symbol with a negative sign. The hydrogen didn't lose its electron, so it isn't a 1 plus charge. The electron is just spending more time around chlorine. So hydrogen ends up with a slight partial positive charge. We use the same funny symbol, but put a positive sign next to it. The end of this molecule now has a slight charge and can interact with other charged atoms, molecules, or electrons. Let's try showing the next example, hydrogen and oxygen. This will be a water molecule. Hydrogen has 1 valence electron. It needs 1 more to fill its outermost shell. Oxygen has 6 valence electrons and needs 2 more to fill its outermost shell. They begin by pulling on the other's electrons, trying to pull it into its own outermost shell and fill it. We once again have that tug-of-war match. Let's determine which element is stronger by finding the difference in electronegativities. Oxygen is 3.44, hydrogen is 2.2, so the difference is 1.24. This is a polar covalent bond. So oxygen is just a little stronger than hydrogen, but not strong enough to totally take the electron and become an ion. So oxygen starts pulling on the electron from hydrogen, and hydrogen is pulling on 1 electron from oxygen. Since neither element is strong enough to totally pull the valence electron from the other element, the 2 electrons end up getting stuck in the middle, and we say they are shared. The hydrogen has its own electron, plus the 1 being shared from oxygen gives it 2, so its outermost shell is full. But oxygen still needs 1 more electron to fill its shell. It will start pulling on an electron from another hydrogen, and that hydrogen will pull on 1 from oxygen. So the oxygen ends up sharing 2 electrons, 1 with each hydrogen. We call this a covalent bond. We write it using an electron-dot diagram where the pair of shared electrons are placed between the 2 atoms. We write the chemical formula as H2O because there are 2 hydrogens and 1 oxygen. You will often see a single bond between 2 atoms, that is 1 pair or 2 total shared electrons, written like this. Here's a video animation from the Covalent Bonds Gizmo simulation on ExploreLearning.com. It shows the bond taking place. The oxygen shares 1 electron with the hydrogen, and the hydrogen shares 1 back. But the oxygen still needs 1 more, so it shares 1 electron with the other hydrogen, and that shares 1 back. The 2 pairs of shared electrons both orbit the hydrogen and the oxygen. But oxygen's 4 valence electrons that are not involved in the chemical bond only orbit the oxygen. This is a polar covalent bond, which means since the oxygen is slightly stronger, it can pull electrons closer to it than the hydrogen, so it ends up with a slightly negative charge, while the hydrogen atoms end up with a slight positive charge. This means the molecule can interact with other charged atoms, molecules, or electrons. Here, a balloon is rubbed on my hair and picks up a negative charge. When it comes near the water, it's able to attract the positive part of the water molecules and causes it to bend towards the balloon. Let's try showing the bond between phosphorus and bromine. Bromine has 7 valence electrons. It needs 1 more to fill its outermost shell. Phosphorus has 5 valence electrons and needs 3 more to fill its outermost shell. When a phosphorus comes near a bromine, it begins pulling on one of bromine's valence electrons, trying to fill its outermost shell. The bromine starts pulling on one of phosphorus's valence electrons. We once again have that tug-of-war match. Let's determine which element is stronger by finding the difference in electronegativities. Bromine is 2.96 and phosphorus is 2.19, so the difference is 0.77. This is a polar covalent bond. So bromine is just a little stronger than phosphorus, but not strong enough to totally take the electron and become an ion. So bromine starts pulling on the electron from phosphorus, and phosphorus is pulling on 1 electron from bromine. Since neither element is strong enough to totally pull the electron away, the 2 electrons end up getting stuck in the middle, and we say they are shared. The bromine has its own 7 electrons, plus the 1 being shared from phosphorus gives it 8, so its shell is full. But phosphorus still needs 2 more electrons to fill its shell. It will start pulling on an electron from another bromine, and that bromine will pull on 1 from the phosphorus. So the phosphorus and the second bromine end up sharing electrons, 1 from each atom. The second bromine now has 8, and the phosphorus now has 7. The phosphorus will start pulling on a valence electron from a third bromine, and that bromine will pull on 1 from phosphorus. So the third bond occurs. Now each bromine has its own 7, plus 1 being shared from phosphorus, giving it 8. The phosphorus has its 5, plus the 3 being shared, that's 1 from each bromine, giving it 8. We call this a covalent bond. We write it using an electron-dot diagram where each pair of shared electrons are placed between the 2 bonding atoms. We write the chemical formula as PBr3 because there's 1 phosphorus and 3 bromines. You will often see a single bond between 2 atoms that's 1 pair or 2 total shared electrons written like this. This is a polar covalent bond, which means since each bromine is slightly stronger, it can pull electrons closer to it than the phosphorus and end up with a slight negative charge, while the phosphorus atoms end up with a slight positive charge. This means the molecule can interact with other charged atoms, molecules, or electrons. Here are some tips for showing covalent bonds. First, write the electron-dot diagram showing the number of valence electrons for each element. You can then determine the difference in electronegativity to figure out if it's an ionic bond or a covalent bond. If it's a covalent bond, whatever the atom needs, that's what it will share to get the same number back.